What if you traveled 10 quintillion years into the future? Today, we're going to go on a journey. 10 quintillion years into the future. A time where our universe will look and act completely different. Stars will have died out. Black holes will form. Earth will be a distant memory. Before we get started, let's clear up how many years we're going into the future. What is 10 quintillion years anyway? Well, it's a 1 followed by a 19 zeros. Yeah, it's pretty big, 10 billion billions. We can't even squeeze all those zeros onto your screen. But never mind that, we've got a lot of ground to cover. Let's start 1 billion years into the future, where something terrifying is happening. 1 billion years in 1 billion years, Earth will look incredibly different. What was once our blue marble, full of life, is now a dull brown rock with no life to be seen. Changes to our sun have killed all life on Earth. The sun has been growing hotter and hotter, about 1 degree more every 100 million years, and the surface temperature of Earth is now 47 Celsius, 117 F. That's 117 Fahrenheit. This increase in heat first disrupted the carbon cycle. Plants died off, then animals shortly thereafter. There might have been a little bit of life left in our oceans, but then it got hotter and the water evaporated. What was once a beautiful planet teeming with life is now a dry, dead rock. But what about us humans? Well, hopefully we made it out of Earth and built colonies somewhere else in the galaxy before the sun decided to kill us. But you wouldn't catch us living on Mars, even that would be too dangerous. With this hotter sun, we humans would need to be living much farther away. We'd need to set up shop in other galaxies within the Milky Way. Hopefully within 1 billion years, humans have developed an efficient system of populating habitable planets. By this time, a populated Mars would be a distant memory. But it's possible that the outer planets in our solar system, or their moons, might become habitable for us for a little while. There's also another possibility. There may be a subset of humans who live on in the form of pure artificial intelligence people, who have uploaded their consciousness into machines and live virtually forever. But the machines that host them? Well, they'd need to be powered by something, somewhere. So physical humans would still be around. And set up these colonies that will keep our virtual humans going? Living forever with the virtual consciousness sounds cool, right? But here's the catch. None of these mind-bending possibilities can happen in our future without the right energy solutions. We're already struggling to sustainably power the things we have now, so how can we expect to fuel such an advanced existence? Well, if we want to evolve into a civilization filled with extraordinary advancements, we need to start developing cutting-edge technology to power it. Thankfully, a publicly listed company called Hillcrest Energy Technologies is tackling right now. They're creating innovative solutions that make energy conversion more efficient and boost the performance of electric vehicles and renewable energy systems. Take their zero-voltage switching, or ZVS inverter, for example. It's a device that converts electricity. Let me break it down. Solar panels generate direct current or DC electricity, but our buildings, homes, and power grids we use require alternating current or AC electricity. To make energy from solar panels usable, an inverter is needed to convert DC into AC. That's where Hillcrest comes in. Their ZVS inverter is a game changer. It operates at an incredible 99.7% efficiency, reducing energy loss and offering potentially millions of dollars in additional revenue for renewable energy projects. Now, you see how they're shaping tomorrow's power systems. Their tech could reduce battery pack sizes in electric vehicles by up to 15%, cutting costs by thousands of dollars per vehicle. And with potential applications in Formula E racing, data centers, and grid-connected energy systems, they're already catching the eye of major players. Click the link in the description to learn more about their technology and products. It's reassuring to know that the electricity challenges we face today are being actively tackled with innovative solutions while helping the planet. If we're going to have a future filled with such extraordinary possibilities, we'll need a company like Hillcrest to help power it. But this is just the start of where our future is headed. Let's hop back in your time machine and go forward another few billion years. 10 billion years time for your next stop, 10 billion years into the future. As you're flying in your time machine, you notice that the solar system looks very, very different. The sun is now much smaller. It's about the size of Earth. It's also white and much dimmer than before. Well, over the last 9 billion years, the sun burned all the hydrogen in its core. As its shell started burning, it became a red giant. Finally, with all of its fuel burned up and with it reaching an older stage in its life as a star, it became a white dwarf. That's what you're seeing now. During its red giant phase, the enormous energy given off by the sun caused its outer layers to expand, engulfing Mercury and probably Venus too. It looks like Earth has been vaporized and is stripped down to its iron core. At this point, the sun will cool off for billions of years before it reaches its next stage, a black dwarf. More on that in a minute. As the sun was getting older and dying out, another big event was also happening. Two massive galaxies merged with each other, creating an entirely new galaxy. You've got the Milky Way galaxy, which is the one we live in, and then our neighboring galaxy Andromeda. Both galaxies are part of a shared space neighborhood containing 50 galaxies. These are called the local group. And due to gravitational forces, some were moving closer together. The Andromeda galaxy moved towards the Milky Way at 400 million km per hour, 250 million miles per hour. If you stood in the middle as they merged, you'd probably feel like you were in the middle of a giant snow globe that had been shaken violently. Except instead of fluffy snow being thrown around, it's rocks, planets, and entire stars. This went on for millions of years. When these two galaxies were finally merged, they created what's known as the Milkomeda galaxy. Would stars have collided during this merger? Well, you might think so, but probably not because of the vast distances between them. They're really far apart. We're talking hundreds of billions of kilometers. But what would happen to our solar system in this merger? Well, scientists have calculated there's a 50% chance our solar system would be pushed far away from the galactic core, 3 times further away from where we are today. And there's a 12% chance our solar system would be completely ejected from this new galaxy. But by that point, we humans would no longer be living in our solar system. If we were still around, we'd have populated planets in a galaxy far away. And we'd definitely choose one that wasn't about to go through a merger. So, say goodbye to the Milky Way galaxy and say hello to Milkomeda. Alright, now it's time to check in and see what else is happening in our universe. 22 billion years in 22 billion years, things start to get a little complicated. Something is going to happen that's known as the Big Rip. According to one theory, we're heading to a point in about 20 billion years where the universe is going to tear itself apart. This will be due to dark energy. Yeah, dark energy. Now that's something physicists don't even completely understand. But they do know one thing: it's causing the universe to expand faster and faster. Keep this dark energy in mind as we'll come back to it later. Now, if the Big Rip happens, galaxies that exist today in clusters will begin to stretch apart. Then all the objects within these galaxies will move away from each other. Star systems, planets, everything will accelerate away from one another, right down to their atoms, which will rip apart and dissolve, leading to the end of the universe. Scientists have found some evidence that we could be heading towards this demise, but it's not 100% certain. Good, I was getting a little nervous there. Okay, so for now, let's assume that our universe doesn't rip apart 20 billion years from now. But what happens next? 100 trillion years, even though the Big Rip may not happen, that doesn't mean our universe will be safe. Over these 100 trillion years, stars all across the universe will be dying out. Let's go back for a second to the Big Bang when the universe began to form. 150 million years after that, stars were created. Now, since the formation of that first star to where you are now, new stars have been and still are forming all the time. The best way to see this is, if you peer into these clouds of interstellar hydrogen gas that are everywhere in space, if you look at a dense area, you can see how it collapses in on itself and leads to the formation of a star. Over the 100 trillion years, you'll notice that stars are forming in all different sizes. The basic rule is, the smaller the star, the longer it lives. Look at this star. which is just under 8% the mass of our sun. It's just a little too small to get hydrogen fusion going, so it's a failed star. Also known as a brown dwarf. And here's a bigger one, about 10 times as massive as our sun. It burns hotter, and it's blasting through its fuel very quickly. So in about 20 million years, it'll die out. And you already saw how our sun died after about 10 billion years. But the majority of stars you've seen are smaller than our sun. These are red dwarfs. They're about 8% to 50% the mass of our sun. They're a lot dimmer, but they also live longer. About 100 billion years. So, during this time, you'll start to see a lot of these red dwarfs starting to die out. Then we've got the brown dwarfs. These are so dim that they're hard for you to see. They die in a mellow kind of way, getting cooler and cooler. As they cool, their temperature will drop to 2,500 Celsius, which is cooler than most stars. Finally, let's check out the end of this incredibly massive star. It's 8 times the size of our sun. Its core is collapsing into a massive explosion that creates a supernova. This gives rise to a neutron star, which is an incredibly dense and compact star. Or its death could result in a black hole. Over these 100 trillion years, you've just witnessed the stelliferous era. You've seen stars being born and dying, planets coming and going, and the merging of galaxies. Well, there's also another incredibly important thing that has been happening as our stars have been dying. You see, when stars die, they release various elements and materials out into space. This often leads to new stars forming, but not all the mass of a dying star gets released and available for new star formation. Because of this, the universe will slowly run out of raw materials in the form of hydrogen gas to make new stars. Could this spell the end of the universe? 10 quintillion years, okay, welcome to your final stop, or almost final. Remember, that's 1 followed by 19 zeros. The stelliferous era has ended, and we're in the early part of a new time called the degenerate era. And no, that's not when a bunch of Redditors take over the universe. As you fly through the universe, it appears much dimmer than it did before. Once twinkling with bright stars, it's now a graveyard. This is a universe littered with the remnants of dead stars. White dwarfs, brown dwarfs, neutron stars, black holes. All the stars that have ever been born have given up their light and died. So, if star formation is over, what happens to humans? Even if we're living in other galaxies, we still need a solar system and a viable planet to live on. Well, one possibility is that we've given up our material bodies and we're existing entirely in the form of energy. Oh, that's cool. But there's another possibility involving a whole new universe. More on that in a second. But back in the degenerate era, keep your eyes open for rare collisions between remnants stirring things up in the universe. Like if 2 brown dwarfs collide, it might give birth to a new star that lives for trillions of years. Or if 2 white dwarfs collide, you could see a supernova explosion. But overall, the universe is becoming cooler and darker. Matter and its tiniest building blocks continue to decay. Alright, that's our 10 quintillion years. Pretty crazy. But what happens after that? What happens at the end of the universe? 10 decillion years, okay. At 10 decillion years, that's a 1 followed by 34 zeros. You are close to the end of the degenerate era. White dwarfs, brown dwarfs. Even neutron stars will begin to die. Their death will come about because of a process called proton decay, where the tiniest subatomic particles that they're made of begin to disintegrate and die themselves. These white dwarfs will no longer be giving off an immense amount of light. Instead, they'll have the brightness of just a few light bulbs. The time it takes for this decay to be completed is incredibly long. But hey, on this journey you've got all the time in the world, or maybe I should say universe. It's sad to see those little protons die out. Well, you couldn't really see them dying because they're so tiny, but still. If the fundamental building blocks of molecules ultimately decay, it would appear that the fate of the universe is sealed. With protons disintegrating, on your last stop, you'll confront an old, unstoppable enemy. 10 duodecillion years, you're at 10 duodecillion years in the future. That's 1 followed by 40 zeros. A lot of zeros, right? You've climbed another rung in the desolate universe. Things just keep getting bleaker and bleaker. There are no planets, no stars, no dwarfs. No wonder it's so dark. You can barely see anything other than a very, very weak shine. These are the black holes. It's no surprise that some scientists have labeled this time the beginning of the black hole era. Black holes are these massive structures in the universe that suck up anything that gets close to them. Not even light can escape a black hole. Now they're like some kind of planetary zombie, scarfing up the remnants of dead stars, and getting more and more dense and massive. And you thought Thanos was bad? Did I mention that nothing escapes a black hole? Yeah, nothing can escape a black hole. Well, there is one thing that can escape. It's been proposed that black holes might leak tiny bits of radiation. This is known as Hawking radiation. Here's how it works. Twin particles are appearing in space all the time, immediately annihilating each other. But when they appear at the mouth of a black hole, sometimes one falls into the black hole while the other escapes. Over trillions of years, this particle leakage would reduce the mass of the black hole, causing it to die. So if you did multiple stops in the time machine, you could watch these black holes eventually die out over massively long periods of time. Alright, looks like there's still some time in the video, so let's check out what happens. Google years okay. Before we get to our last stop, for real this time, I gotta mention the What If Explorers Club over on Patreon. For just a couple bucks a month, you can get exclusive ad-free videos. Check it out in the description. Okay, a Google years into the future. What is that? That's 1 followed by 100 zeros. What's happening here? Well, even the last black hole in the universe has lost its last bit of mass and died out. Welcome to the dark era. It's cold, dark, and very quiet. What can you see in our universe at this point? Well, only a few subatomic particles and dark energy. The universe has expanded so much that the few subatomic particles left are super spread out, incredibly far away from each other. At one point there were stars and then remnants of stars, then black holes, but now you'll have to zip around in the time machine all over the area of our current universe to catch sight of a single subatomic particle. What a sad and lonely place. And remember the dark energy? The stuff that almost destroyed the universe during the Big Rip? Well, it will keep the universe expanding out further and further. And as the universe keeps expanding, what if you traveled 10 quintillion years into the future? Today we're going to go on a journey. 10 quintillion years into the future. A time where our universe will look and act completely different. Stars will have died out. Black holes will form. Earth will be a distant memory. Before we get started, let's clear up how many years we're going into the future. What is 10 quintillion years anyway? Well, it's a 1 followed by a 19 zeros. Yeah, it's pretty big. 10 billion billions. We can't even squeeze all those zeros onto your screen. But never mind that, we've got a lot of ground to cover. Let's start 1 billion years into the future, where something terrifying is happening. 1 billion years in 1 billion years, Earth will look incredibly different. What was once our blue marble, full of life, is now a dull brown rock with no life to be seen. Changes to our sun have killed all life on Earth. The sun has been growing hotter and hotter, about 1 degree more every 100 million years, and the surface temperature of Earth is now 47 Celsius, 117 F. That's 117 Fahrenheit. This increase in heat first disrupted the carbon cycle. Plants died off, then animals shortly thereafter. There might have been a little bit of life left in our oceans, but then it got hotter and the water evaporated. What was once a beautiful planet teeming with life is now a dry, dead rock. But what about us humans? Well, hopefully we made it out of Earth and built colonies somewhere else in the galaxy before the sun decided to kill us. But you wouldn't catch us living on Mars, even that would be too dangerous. With this hotter sun, we humans would need to be living much farther away. We'd need to set up shop in other galaxies within the Milky Way. Hopefully within 1 billion years, humans have developed an efficient system of populating habitable planets. By this time, a populated Mars would be a distant memory. But it's possible that the outer planets in our solar system, or their moons, might become habitable for us for a little while. There's also another possibility. There may be a subset of humans who live on in the form of pure artificial intelligence people, who have uploaded their consciousness into machines and live virtually forever. But the machines that host them? Well, they'd need to be powered by something, somewhere. So physical humans would still be around. And set up these colonies that will keep our virtual humans going? Living forever with the virtual consciousness sounds cool, right? But here's the catch. None of these mind-bending possibilities can happen in our future without the right energy solutions. We're already struggling to sustainably power the things we have now, so how can we expect to fuel such an advanced existence? Well, if we want to evolve into a civilization,